Hey guys, welcome back. Today we're going to do something new, integrating using inverse trig. And you've already done derivatives of inverse trig. We did that first semester, but you may not remember that. So we're going to start by reviewing doing the derivatives with inverse trig. Okay, here were the derivative rules. And I'll give you a little reminder of how we tried to memorize these. Remember, honestly, the first two are the ones you really need to know. This one, the third one, inverse secant, you're supposed to know this one also, but it's not really that common that they ask it. So really focus on the first two. Now, when we tried to remember this, we said, remember, they all have a 1, another 1, and a u squared, a 1, another 1, and a u squared. The du at the end means do the derivative of whatever this is, and don't forget that. And then we said sine starts with an s, and it has a square root and a subtract, all s's. Tangent has a t, which kind of looks like a plus sign, okay? So try to memorize those. These are also, remember, all of your formulas are in the front cover of your book, like cardstock, okay? So those are your derivative rules. We also have integral rules that are very similar, okay? These are the integral rules that are also written in your book, but let's do some more with the derivatives before I start introducing the integral rules. Okay, so if we were to do the derivative, first we got to remember that formula. So the formula for inverse sine, they all have the 1, and the u squared, and the du. Inverse sine has an s, so it's the one that has a square root and a subtract. So remember from first semester, figure out what the u is and what the du is right off the bat. The u is the thing that's right behind the inverse sine, so my u is going to be 2t. Du is the derivative of that, okay? Now we're not integrating, we're doing the derivative. This says to find the derivative, we're going to do all of this. So the derivative of this guy would be 1 over the square root of 1 minus u squared. 2t times 2t is 4t squared times the derivative of u. So multiplied by 2, and we would just put the 2 up here. Okay? That's doing the derivative using inverse trig formulas, and that's your answer. Okay? But today's lesson is going to be reverse. Today is going to be when we integrate this, we should get this. Okay? So now the next problem is going to be, how do we find the integral of that? Okay, so let me show you your integration formulas. And just like with derivatives, it's really the first two that you want to really know, and just understand that this third one exists. Okay, so first of all, notice that inverse sine or arc sine, same thing, still has a square root and a subtract. Okay? Whereas tangent, t plus. Okay, but we're going to be starting with this, and we have to write this. So when you try to write these formulas, you're going to remember that sine has the square root and the subtract. Okay? They all have u over a, and that's this guy over this guy, the square root of those. Okay? They all have the u over the a. Tangent, however, has extra thing. It has a 1 over a in front. Inverse tangent has a 1 over a in front. So the way I try to remember that is tangent gets a title. Tangent gets a title. It has a number out in front. The short of it is you do have to memorize these two formulas, unfortunately. Okay? So write them down or print them out. I gave you some notes that have them already so that you can print them out easily. Or take a picture with your phone. Take a picture of that page in your book, okay? So now what does the a and the u stand for? U is always a function in terms of x. A is going to be a number. Okay, try to remember a is a number, u is a function. All right, now let's apply it to a problem. Okay, this is the problem that we just had as an answer to the last problem, okay? So, working it in reverse. First, we got to remember, how do you even know when to do this, okay? It's the perfect squares that are kind of your hint as to when these problems are inverse trig problems, okay? So the two perfect squares in the denominator, the 1 and the 4t squared, that's kind of your hint. Also, regular u sub doesn't work. Because if I tried to do the derivative of this entire denominator, if we tried to do it like normal u sub and I let the u equal the entire thing, then du would be a negative 8t, and I don't have a t up here, and I can't just add a t like I can an 8. So regular u sub doesn't work. So then you think, ooh, perfect squares, maybe it's one of those inverse trig things. And then you go on and proceed as though it is and see if you can get it to work. Okay, so first we need to make sure we have this format in the problem. So notice we're going to need to have du in the problem. Okay, so write down what your a is and what your u is. A, always write down your a and your u and your du. A is the number you're squaring, so a would be 1. U is the function you're squaring. What am I squaring to get a 4t squared? 2t. Always find du also. You still need du in the problem. The derivative of 2t would be 2. Now you're going to rewrite this, at least in your mind, if not on the paper, okay? You can get to the point where you can kind of do it in your head, but you should rewrite it. Rewrite all of this in terms of u's and du's, okay? So we have the integral of. On the bottom, this is a squared minus u squared. So on the bottom, this would be the square root of a squared, and this was u squared. On the top, we have 2 dt, so I should have really had that here, but that's actually my du, which I can put here or I can put it up here. So basically, you just need to make sure that you have everything that the formula requires in the problem. So I haven't done anything yet. I just need to verify that I have the a squared, the u squared, and the du, and I've got all of that. Now we do the work. We apply the formula. Well, the formula for inverse sine, okay, it's inverse sine of u over a. They're all u over a, and that one doesn't have a title, okay? So now that we know we have everything we need in the formula, we go straight to the answer, and the answer is inverse sine of u over a, or just inverse sine of 2t. And that was the question that we started with. All right, it seems harder than it is. It's going to take another couple of examples before you get it, but it's not that bad. Mostly, all of the real work comes from making sure that you have everything you need in order to apply the formula. Once you know you have everything you need, you just do this real quick, and it's super simple. All right, let's try another one. Okay, first, why is this not regular u sub? Why can't I let the entire denominator be my u? And that's because if I let the entire denominator be my u, then my du would be 50x, and I don't have an x up here. Okay, so I can't use regular u sub, it just doesn't work. So then I go, oh, perfect squares and a fraction. I bet it's one of those inverse trig things, okay? And this one has a plus, so I'm going to assume that it's inverse tangent, and I'm going to try to make that happen. So I have to remember my inverse tangent formula. The integral of inverse tangent. Oops, I wrote that backwards, completely wrong. Okay, the integral for inverse tangent was 1 over a squared plus u squared du. Remember, tangent has a plus. Okay, now if I can get this to happen, what it will equal is inverse tangent of u over a, and tangent gets a title. Okay, you got to memorize the formulas. This is all formula that you just have to memorize. Okay, but I can't apply the formula unless I have this to begin with. Okay, so I've got to make sure I have that. I'm going to write down my a, which is the number we're squaring. My u is the function we're squaring, and du would be 5. Well, I have to have the du in the problem, just like normal u sub, and I don't have a 5, and I have to have that 5, so I'm going to put a 5 here and a 1/5. And this is really where all the work happens. Now you just got to make sure you have everything required to apply the formula. Okay, do I have a squared? Yes. Do I have u squared? Yes. Do I have du? Yes. So now I'm going to give my answer. Well, there's a 1/5 out front, so I got to bring that down. And now I simply apply this formula. So I'm going to have a 1/5 out front. 1 over a is 1/3. Inverse tangent of u over a, 5x over 3, plus c. And that's it. Okay, and you would change this to 1/15. All right, let's try another one. Okay, again, usually you're going to start with regular u sub, and you're going to try to do like we did all the work the last couple days. And you go, oh, I'll just make the entire denominator be my u. But if I do that, then du would be a negative 4x cubed I don't have the x cubed, so it's not regular u sub, okay? So you really have to think about that each time, because on your next test, you're going to have regular u sub and inverse trig. All right, so now we go, oh, this is a perfect square. This is also a perfect square. Maybe this is inverse trig, all right? Well, it has a square root and a subtract, so I'm going to go for this guy, okay? I'm going to try to make that happen. All right, so assuming that it's inverse sine, I'm going to write down what my a is, which is the number being squared. My u is the function being squared. What do you square to get an x to the fourth? X squared. Du, I figure out myself, that's a 2x. I don't have the 2, but I do have the x, so I'll put a 2 here and a 1/2 here. And that's really the gist of the work. Now we just plug it into the formula, okay? If there's ever anything in front of the integral, we bring that down. Now all of the stuff behind the integral goes to this formula. So I have inverse sine of u over a. Done. That's it. Okay? Hopefully that makes sense. Now it's just a matter of practicing it. Okay? So these are the two formulas you need to know. You need to make sure you have all of this. So always write down your a, your u, and your du. If you don't have the full du, if you can add a number, but you can't add a variable. Once you have everything you need, you just apply the formula. So now what you really need to do is memorize your formulas. So let's go over that again. Okay? In these formulas, sine, inverse sine, square root subtract. Okay? Tangent starts with a t, looks like a plus. And you basically have to recognize these things. Ooh, that looks like inverse sine. Ooh, that looks like inverse tangent. And it's always u over a. So number or function over number. And tangent gets a title. Try to memorize those right now. Stare at it right now. All right, we're going to do one more problem that has bounds. So it's a definite integral. Oops, I lied. First, why is this not inverse trig, even though it looks very similar? Okay, for this one, again, you should always try regular u sub first. And if we let the entire denominator be my u, then du would be 2x. That works. Whereas inverse trig won't work because you'd have an extra x in the numerator that would be throwing you off. Okay, so this one we would do with regular u sub. The entire denominator is my u. This is my du. This ends up being a natural log problem. Okay, so I'm not going to mess with you today. Like today, you're going to do all inverse trig, but you should each time think about why it's not regular u sub. Okay, one more with a definite integral. Okay, here we go. So again, it's not regular u sub because I don't have the derivative of the bottom on the top. So I go, ooh, I see perfect squares. I see a fraction. It looks like inverse sine. If it is inverse sine, then I will need my a, my u, and my du. Okay, a is going to be the number I'm squaring. U is going to be the function I'm squaring. Du is 1. I got everything I need. Okay, so I'm going to just do the problem without bounds for right now. Let me back up a bit. So I think I'm going for this, which is the inverse sine formula. Okay, got to make sure I have everything for that. And if it is inverse sine, then my answer will be inverse sine of u over a plus c. Okay, do I have everything I need in order to apply the formula? Do I have a squared, u squared, and du? Yep. So I'm going to go straight to my answer, which is inverse sine of u over a. Okay, but I don't need the plus c because now we're going to plug in our bounds. Okay, so just like normal, fundamental theorem of calculus, plugging in the square root of 3 and then plugging in the square root of 2. Now, unit circle, here we go. This is asking when does sine equal the square root of 3 over 2, and this is asking when does the sine equal square root of 2 over 2, okay? Okay, sine is equal to the square root of 3 over 2 right here, which would be pi over 3. Sine equals the square root of 2 over 2 here in the middle. Hopefully you guys know that one. That's pi over 4, okay? Now you get a common denominator, change them both to twelfths. So multiply this one by 4. Multiply this one by 3. Common denominator is 12. So in the numerator, it would be 4 pi minus 3 pi, which is pi. And that's your answer. Okay, now, when you're dealing with inverses, there's a stipulation that you're only allowed to use certain quadrants, never this one. It's probably not going to come up because usually just your first positive, obvious answer is the one that works. But for inverse sine, you're only allowed to use these 2 quadrants. And for inverse tangent, it's also these 2. Cosine was these 2. I don't think it's going to be an issue. It's not going to matter. Just keep on trucking. Let me know if you have any questions. Okay, so your worksheet today is going to review derivatives and integrals. I gave you some notes so that you could print this out easily. Your next test won't have derivatives on it. It'll probably just have integrals on it, but I wanted you to review it all together so that it makes sense, okay? So probably these are the 2 most important formulas for you to know. I won't be asking this, but you should know that it exists. Same thing over here. All right, good luck, guys. Thank you for asking all your questions and asking me to make videos. Keep them coming, okay? Bye. Sorry it took me a while to explain that one. Don't be shy about telling me that I didn't explain it well enough and make me work again, okay? Bye.